This afternoon, I'd like to talk a little bit about what we do, why we do it, how to use the information from Environment Canada, how to make the best use of it. And so far, like in the past year and a half, we haven't talked about weather. Like we've talked everything that kind of goes around weather, like the implication of weather. But as a farmer, like you're concerned about weather conditions on a daily basis, on a weekly, and also during the growing season, and even in the winter time, you'll see that we're also concerned about weather conditions, snow cover, refurbishing of the moisture in the soil, and so on. So weather is an element that we're concerned about, that we have to monitor year-round. And again, I just want to acknowledge today Linda Levy, if you want to raise your hand. Linda is the warning preparedness meteorologist in Charlotte. She's in Charlottetown. I'm in Fredericton. So I am the liaison between the forecast office, the Atlantic Storm Prediction Center located in Halifax, in Dartmouth, and the clients in New Brunswick, and Linda is doing the same with the clients on the island. So within the next half hour, we're going to talk about what I call the W's of Environment Canada. Then we also have the new climate normals. Like we're in 2014, we have the new climate normals, 1981, 2010. Every 10 years we do these climate normals. And whatever was normal a couple of years ago, now it's become the extreme or vice versa. So we're going to look at some changes taking place in these like climate trends and changes taking place in the normals. And then Margaret also asked me to talk a little bit about the AgWeather website using the Mesonet different network. There's lots of flexibility in inquiring weather information, past, present, and also forecast. So I'm with the branch of the Weather Service. We also have conservation or sustainable development. We have enforcement officer. Linda and I are with the weather sections with the Meteorological Service of Canada. And we're all part of the Atlantic region. And once again, all the weather information, Linda and I, we don't do weather forecasts, so you can't throw any tomatoes at me. But we are the liaison between the official forecast from Environment Canada, the Storm Prediction Center, and the end users. We're all familiar with the weather forecast, whether you get it from Weather Network, from Boomer, from AccuWeather, from our source of Environment Canada. But at the Weather Service, that we're doing more than weather. As you see on this slide, that we're looking at air quality, we're looking at the climate, we're gathering all this weather information from various sites across the Atlantic region. We're not doing anything specific with El Nino, La Nina, but we're kind of monitoring the evolution, see if it has an impact in Eastern Canada. Ice information, so the Canadian Ice Service is under the umbrella of the Weather Service. Looking also at UV radiations, looking at the water quantity. This morning we did talk about the buffer zone, so on. So we're not looking at water quality, but we're looking at flow and water quantity monitoring across the island. As introduction slide also, and because we're in February and we're, I guess, slowly thinking about what am I going to do crop-wise in the spring, or you may have made a decision already. On this slide, we're really looking at a special year, special winter season. This is the weekly ice chart looking at Eastern Canada. We're looking at the Gulf of St. Lawrence, Northumberland Strait, and you don't see very well on this slide, but we had an early start of ice formation in December. December was very cold. And we had, this is the median, so the average over the past 30 years. And this year we had an early start of ice formations. We were, I'd say, like significantly above normal, because the past 20 years or so we've been below the normal for the ice coverage, and it has an implication on our climate and on our weather. So this is the January thaw. Okay? Everybody had this famous January thaw. For 8 consecutive days, temperatures not quite in the double digit, but sometimes even the overnight temperatures stayed above freezing. So it's funny, we did melt quite a bit of ice. So again, that's the average weekly ice coverage. And then we're back into the cold period. And you see that we're just about to peak. This one was from, actually that's from this week. And we're just about, we're still building ice depending on weather conditions. And we're going to have a well above normal ice coverage, looking at the weekly coverage. This one here is looking after the annual coverage. So this winter is well above the normal. We have to go back to the winter of 93, 94 that we had that much ice. So you see that in the past 20 years we had less than normal ice coverage over the area. So what it means, and someone mentioned it this morning, it takes 4 times as much energy to melt ice than to warm air temperature. So in the spring we have all that much ice on in the Strait and the Gulf. So we have to melt more ice, and the water will be colder, so it will take a bit longer. So you'll see when I will show some of the maps of the monthly, like what we can anticipate weather-wise in April and May, that maybe we'll have a late spring. Even though when we talk about climate trend, there's still a warming trend. So just going briefly, Linda and I are the liaison. Our main mandate with the Weather Service is the provision of weather information, especially weather warning for the public safety, security, and also the economic prosperity. So it's our part of our responsibility to contribute to the Agriculture Department for the economic prosperity. Climate, weather in the Maritimes, sometimes people don't realize that we get it all. You look at all the warnings, all the weather elements that we monitor in the Atlantic region. I mean, we have it all. The only warning that I haven't seen yet here is the dust warning. When I was out in the prairies, that sometime in the spring we used to have these dust warning, and I haven't seen any in Eastern Canada. But otherwise, we get everything. You see that rainfall, we have it in winter and also in the summer period. It's based on impact. In the winter time, our criteria to trigger a rainfall warning is 25 millimeters of rain with a weather system that will trigger rainfall warning. In the summertime, we're talking about 50 millimeters with a storm system. So all these warnings we can see almost any time on the island. Also, we have, just to make it somewhat complicated, we have warnings, watches, advisories, and special weather statements. So when there's a weather warning, like this morning, not in Prince County, but in Queen and Kings, we had snowfall warning, so there's imminent, actually it was almost a nullcast, I believe. So we did, but when there's imminent occurrence of, let's say, severe thunderstorm or wind or snowfall warning, so we issue the snowfall warnings. If there's the potential, then we issue a watch. So in the summertime, we see severe thunderstorm watch. So it indicates the mass is unsettled. There's likelihood, there's possibility of a thunderstorm developing in the afternoon and so on. And advisory sometimes is issued when there's 2-3 days lead time. So we're not too sure the specific track of the system, but hey, we may see a storm in the next couple of days. And the special weather statement also is the first kind of heads up. We issue this general bulletin. There's a bomb that may develop in the U.S. seaboard, may impact the maritime, let's say, over the weekend. So it's almost like sometimes up to 4 days of lead time. We do have in the archive like some information that we got atmospheric hazards, and wondering like on the island, so should I be more concerned about snowstorm, rainfall, frost, and so on. So we have this website, Atmospheric Hazards, that provides additional information. So it's not forecast, it's based on data that we've gathered from whatever the sites that we, information that we have available. So you may be interested in days with rainfall, days with snowfall, total snow accumulation, so on. One of the issues also on the island is storm surge. So you look at on this slide, so the return period, sometimes we look at return period, 25 years, storm surge. Every season, like we do get storm surge, we get erosion, we track conditions. This is looking after on the hazard website, and this is more of the short term. We have this computer model that looks at astronomical tide, because the FO will publish the tidal cycle like a year in advance, and then we blend it with weather conditions, and then we come up with a forecast of anticipated total water level. So you have on this line here is the astronomical high tide, and then we know that the contribution of weather factors, whether it's extended period of northeast winds or very low barometric pressure that will contribute to a swelling of the water level. So if that coincides, if the timing, the motion of that system coincides with astronomical high tide, if you're at full moon or new moon, if you're at perigee or apogee, so this is all considered in, and then it provides some information on the actual water level of storm surge. One of the elements also that we're monitoring in eastern Canada is we have the Atlantic Hurricane Center, also co-located in Halifax. Every season between May and end of November, we're impacted by tropical storm or remnants of tropical storm. One of the tricky factors that sometimes people don't realize is when these systems are off the U.S. seaboard, further south, like in southern latitude, everything is circular, like precipitation, wind, everything around the eye of these storms. Once they start to interact with the jet stream, they become what we call post-tropical storms. So there's change of behavior in the wind pattern and also in precipitation. And you see that where these changes are taking place is just, well, in general, like south of Nova Scotia. So it's in our neck of the woods. So that represents an additional challenge in weather forecasting. As I said, we're monitoring also water level. We're monitoring flow inland. So just around Summerside, so we have the water gauges along the Wilmot River and Dunk River. So in the spring in New Brunswick, we're concerned about ice jam and also flooding. Or this morning we did talk about it. We have a significant rainstorm, so there's implication on water level. So it's sometimes I find it's representative of the watershed, not just necessarily the stream. You remember that you always say that garbage in, garbage out. Well, it works also in weather, so we gather as much information as possible, observations over the land. We gather like radar information from Halifax radar, shipment radar in New Brunswick, lightning information, satellite information, and also from agriculture, natural resource, additional weather information that we take all this material and then it's being used in order to improve the weather forecast. This year also we have a pilot project on what we call COCORAS, is collaborative community of rain, hail, and snow. And you see that we have a couple of volunteer observers in Prince Edward Island, so looking at the snow, water content also in the snow. So you can go on this COCORAS website and check on the sites. You have on the main menu selection of snowfall, water equivalent, snow depth also, and the snow depth water equivalent. So it provides quite a bit of valuable information. This is all taking into account. We have one location in Canada, that's in Montreal, Canadian Meteorological Center, that they run these computer models to predict, to anticipate weather conditions. So again, the observations that's the base. Like if you don't have good observation, it'd be very hard pressed to do a good forecast. So we take all these information laid out on the map, and then we're also looking at 28 levels up in the atmosphere. All these equations, these are approximations, so that's why like weather forecast is not perfect and will never be perfect. And then also the forecaster will look at all this information, add value, produce a weather forecast that you're probably familiar on the internet or weather radio. I mean, there's various means of dissemination, and that's how like everything works. So twice a day we have major like a model run. Our operational model valid for 2 days runs at 10 kilometers resolution. Sometimes Gavin, in northwestern Brunswick and at St. Andre, we have the airport in St. Leonard, and then the farmers will say, well, don't give me the forecast for the airport, I don't care. My field is so many kilometers away, but the short-term forecast for up to 2 days, operational model has 10 kilometers grid point. And once we get beyond day 2, beyond 48 hours, then it's at 25 kilometers resolution. I'll show you some maps of monthly forecast. It's got 200 kilometers resolution. So as you move in time, you move into a more coarse resolution. So the forecaster down in Halifax receives all this raw information, and then will use its training, expertise, pattern recognitions, add value, and then we'll produce the final weather forecast. So on our weather Weather Office website. You click on the map, get on the PI, and then you can select and you click on any of the stations, or you can select also the various points. Then it gives you the latest weather observations, all the weather parameters. Gives you icons of the weather anticipated for the next 7 days. I always tell clients, users to look at the text. Like when you have, let's say today's forecast was snow at times heavy, blowing snow, and late this afternoon, then mix of sun and cloud, 40% chance of flurries. So how can you put everything into one icon? This is the screen capture I did from last night. So you can't. So you have to look at the text. Beyond the text also, personally I'm interested, okay, BI, are the three counties all grouped together? Or this morning the forecast was different for Prince, Queen, and King County. So I'm interested, like you're in a specific location, and I'd like to get the best product possible. Also, once you go on the website, you can look at the normals, the yesterday's max min. You have access to one-click satellite pictures, radar images. So if you're in the southern eastern two counties, it's going automatically to the Halifax radar. If you're in Prince County, then it goes to the Chipman radar. Some of the sites also, we have the air quality health index available. As you can see, there's quite a bit of information past 24 hours. If you're interested in what was the maximum, minimum temperature, maybe interested also in precipitation amounts. Here's one of the slides that I use for the emergency management. For the EMO is one of my main clients, and I found like yesterday we were talking about best management practice. Yesterday the term SMART was used also quite a bit, and in advance of what we call like high impact weather, we're all using the same system. So you've already done initiatives like to mitigate, to prevent the impacts from significant storm. In advance of the storm also, you make sure that there's procedures that you do accordingly in the spreading of pesticides, herbicides. You check on weather information during an event. You check in your field. If there's any damage, impacts, and so on. And there may be also a recovery phase. Like up in the northwest of Brunswick, that once the tornadoes are in the ground, I don't know for whatever reason, we get some severe thunderstorms, and then some of the roads, they're just washed away. You get all these tornadoes at the bottom of the hill. So there's maybe a recovery phase also. So I find the same various steps that we use in emergency management that we use we can use here in the agriculture sector. What Linda and I were doing, like you have access to, all sorts of sources of weather information from various agencies. Environment Canada is the only one that can issue weather warning. So I use the Weather Network all the time. I always double check also what they're doing. But when it comes snowfall or rainfall, severe thunderstorm warning, Environment Canada is the only entity that has the mandate to issue weather warning. And it's the same in the States also. Only the National Weather Service can issue weather warnings, because then we're talking about public safety, security. But what Linda and I, we do, I'd say like somewhat beyond that, is to communicate some information about the urgency, severity, and certainty. So we have access internally to additional information, and you get like a snowstorm, or you get whatever weather event it is. But sometimes you're concerned, well, if I get like a rain, let's say summertime rainfall warning, 50 mils, and that's fine. You can go, let's say the soil has been fairly dry, water table is low, 50 mils is no big deal. And we have a rainfall warning. We may also have a rainfall warning in effect for 150 mils of rain. Then that represents a very different scenario. Same with the, I found we look at the monthly, we do a lot of these monthly summary. And in January, I showed you about the January thought that it was very cold. I was doing some other term, but it was very cold in early January. Then we had this thaw period that was extremely long, like we had 8 days. Then back to frigid, cold temperatures again. I'm looking at the stats for January, where the temperature's been near normal for January, the mean daily temperature, because we had like 15 above, 15 below, but on average it's near normal. Precipitation, 110 millimeters. Yeah, we had the water equivalent of 110, but we had two events, one of 60, one of 40. So sometimes you have to be careful, like in how you make your way around these numbers. And playing with numbers, you can make it say almost whatever you want to. So anyway, back to Linda and I, like, we would communicate information about these three aspects. And the way we do it right now, like, lots of it works in what we call ensemble. So we look, or people look at Canadian models, American models. There's lots of unknowns. Like right now, like we have maximum ice that we've seen in the past 20 years. So how long is this going to last? Is this going to melt rapidly? Does this have an impact on my forecast for tomorrow? So these are all unknowns. But sometimes, like when it's all feeding like various scenarios in the computer model, and at the end of the, let's say, day 2, you see that, well, regardless what happened with it, there's no impact. So that's what we call these ensemble forecasts. Let's say for Charlottetown, that's the one that was done yesterday, and you see that we have like 40 what we call 40 mentors. We use 20 from Canada, 20 from the States, all put together. And we see if the temperature, so this is the temperature, your minimum, maximum, daily values every 6 hours. And the closer like this yellow box is, so it means that regardless of all the, what we call the uncertainty, so I feel pretty confident about the temperature forecast. So if I'm looking at temperature profile, it's fairly consistent up to maybe the weekend, and you see that this yellow bar starts to stretch. So it means that, well, if they go left and right and so on. Same with the precipitation pattern. So your distribution of 40 members may be all compact, all very close together, high confidence level, or it may be widespread. In blue, we have our operational Canadian model, and sometimes you see at this event, like on February 24th, this blue line, that's the only one. So if I look at our Canadian model calling for precipitation on the 24th, but that's the outlier, that's the only one that is calling for precipitation, so I would not put too many eggs in that basket. How many times we hear about these weather systems on the U.S. seaboard, and we'll bring blah, blah, blah. And we also look at, let's say, with all these members, are they all telling us the same story? So you see just two random maps, and it just shows that with this scenario, so if you see like a low pressure system along the U.S. seaboard, and I feel pretty good, pretty confident where it's going to be, let's say, tomorrow night, because everything is very all like converging to the same solution. And if I look at this layout, I see, well, the low pressure system may be well south of the Atlantic coast of Nova Scotia, and actually may tracking close to Charlottetown. And so that may have a significant impact on, am I going to get rain? Am I going to get snow? Are the winds going to be from the northeast or the southwest? So this is all sorts of information that we have internally also. And here's just a plot of all the possible tracks. So again, when we're tracking tropical system or just regular low pressure system, and then we see if all these tracks are converging together, so it just increases the confidence level. Here's the map that we produce, like beyond the like today's forecast and for the next 5 days. We have, as we're getting towards climate information, we have here's a forecast for the 10 days of the mean daily temperature. So on the island, we're calling like the next 10 days. This map was produced yesterday. So up to the 28th of February, we're looking at temperature near seasonal. So that's looking at the mean daily temperature near seasonal values. This one is looking at, we produce like daily these climate map, looking at anticipated conditions for the month of March, looking at various categories. And we're looking at likelihood of below normal conditions. And there's moderate to high confidence level. Remember, like at the beginning of the presentation, I was looking at the ice coverage. So the ice coverage has an impact on our anticipated conditions for temperature regime for the month of March. Here's the latest outlook again that was produced yesterday for March, April, and May. And we see that there's, I say, like moderate level, confidence level in below normal temperature. So the climate trend may indicate otherwise, but this year we have well above normal ice coverage. It takes so much energy to melt this ice, to warm up the here, so chances are that our temperature regime may be below normal conditions. Just turning the page a little bit and now moving to some of the climate change, I guess, behaviors that we've seen in the past many years. And this information comes in from Dr. Fenech with the UPI. We see that, and like some of the slides got information for Fredericton, Charlottetown, but it's very representative of Eastern Canada or the Maritime. So looking at the annual mean temperature climate trends in Fredericton, we see that the temperatures from the normals from 61 to 90 and so on has been moving upwards. In a sense, it's not surprising. We're talking about global warming, and so whatever was normal annual temperature in this period is now at 5.6. And looking at precipitation amounts, actually the precipitation amounts is down by about 5%. And it's a little bit surprising because all the long-term projection of precipitation amount is on the high side. So I'm not sure how significant and what type of signal that this is sending, but we see that the new normals 81 to 2010, so it's always an average of conditions in over a period of 30 years, is down from what it was in the previous normal. Looking at Charlottetown temperature regime since 1873 to 2011, you see that everything is like on the rise, or according to the long-term prediction in general. So temperature rise, and what I find interesting is that the signal seems to be quite noisy in the past decade or so. And there's been quite a bit of interesting study. I find it in like, okay, well, we've seen that the climate, the temperature is on the rise. So where is the contribution coming from? And you see that when we look at the summer period, it's about 0.4, 0.6, and the main contribution comes actually 1.7 from the winter period, and also it comes from the overnight temperature. So much of the warming that we have seen so far since 1873, comes from the overnight minimum temperature kind of moving up a little bit. And we may be interested, maybe planting like early in the season. We see in spring, actually temperature is up by 1 Celsius. Maybe we would like to benefit from a long period of frost-free. And in the fall, the contribution is about 0.6. Another way of looking at it, still in Charlottetown, 1881 to up to 2010. So that's the changes that took place, and divided by month. Looking at the temperature difference, we see again main change occurred in the winter time. So from November, December, and I'm not sure why there's a dip in January, but in general, like it's a major contribution in the winter months. And you see that September, October, so the contribution is minimum with 0.2, 0.3. And then if we look at the early growing season, still a fairly good contribution. Just going quickly with the extreme hot, extreme cold conditions. So we have less of the very cold conditions, which is sometimes good and bad, because some of the disease that you need like temperature of -30 or so in order to get rid of some of the larvae. So sometimes it's good to have some of these very cold temperatures. Looking at the global picture, so 2013 was the 7th warmest year since 1880, and that's looking at over 6,300 observations over land and over water. And even when you group all this into decades, because sometimes there's quite a bit of noise in the annual variation of temperature. If you just blend everything in that 10 years period, you still see that in general, I mean, it's towards the red, so there's a warming trend. El Nino, La Nina, I mean, all the trends are pointing in the same direction. So there was the John Holdren, actually, is the science advisor of Barack Obama, and he made the statement that climate is the pattern of weather weather averages and variation and probability. So it's always difficult to separate like weather conditions versus climate conditions. But climate is the change. The climate change is the change in the pattern conditions. So we're looking at global trend in temperature, precipitation, but also like are we getting more snowstorms? Are we getting more of the blizzard, the snow on ground, and so on? So there's various aspects that we can look at climate, not just from general like temperature, precipitation, but occurrence of specific phenomena. Margaret asked me to talk a little bit about this website. So it's atlanticagrometeo.org. And I'll just give you, I just did some screen capture of what type of information, because you're monitoring like growing degree day, you want to, you probably have your own weather station, you're monitoring precipitation, temperature, want to know the staging of your crop, and this is an excellent tool looking after like your area, but also getting the big picture of the island. So if you go on the AgMeteo website and bilingual site, select Prince Edward Island, always comes back by the way to the last station that you look at displaying the observations, and it's most of the time it's numerical and graphical with colors also of representation of various elements. So if we're looking at let's go back to temperature, air temperature, and it gives you like these are all the locations that are being used. Actually, hourly observation, because everything is updated every hour. So again, color coded and so on. If you click on a specific weather station, that is Summerside, gives you the last weather observations, and then it goes back. It's 7 or 10 days. Gives you this meteograms of temperature, precipitation that we've seen in the past so many days, and it gives you Environment Canada latest forecast. And then you can just change location and select another point also. You can look at maps and you can zoom in, zoom out on the island. So looking at current conditions, and you have this little calendar also that you may be interested in what was the weather like in, let's say, August 15 last year. So you can just toggle along with the calendar. Looking at the air temperature, may be interested in yesterday's maximum, minimum temperature. And again, you can zoom in, zoom out. And as you move your mouse also, like you get specific numerical values. Rainfall, so this one just for the sake of it, I was looking at 2 days rainfall, August 10 and 11 of last year. And then you can select also the beginning, ending of the event. So it's really, it gives you lots of flexibility. Finally, looking at the weather forecast, always from Environment Canada. So you have the tabular forecast, or you may be interested in the graphical forecast or the trend. So looking at the next 14 days, and I'm thinking of all the possible applications it may have on your operations. You may be interested in looping like a map of cloud cover or temperature, precipitation, and this one just brings you to the website of Environment Canada. If you click on the tabular forecast, it gives you the temperature, humidity, the dew point, the wind speed, directions, gives you the precipitation forecast every hour, and also the cumulative precipitation. So you may see from this table, for instance, that let's say the rain is going to begin this afternoon around 4 o'clock, give or take probably an hour or two. So it may give you like several hours to be able to do some operation in your field. And some people prefer the graphical representation, temperature, precipitation, wind speed, direction. Just as you're getting close maybe to a harvest period, you may be interested in like a fairly dry period. So this is the outlook for 12 to 14 days. So you have the temperature and precipitation on top. So looking at maximum, minimum, and precipitation amounts, rainfall amounts in millimeters, and also the cumulative precipitation. Same also with the temperature. Looking at air temperature, so again you can have a map with the ISO lines, so that was the minus 15, and again color coded or animation of various pieces of information. So on the left we have the actual observations, temperature, precipitation, forecast, and then we may also go in the ag weather sections like general, and that's where we get all the statistics for all the points that you've seen on the last before. Cumulative growing degree date, beginning April, beginning March, and this one also a different threshold beginning at various points. But you'll see that from the summary, you can also select, let's say if I plant specific crop, let's say on May 12th, I'm interested in cumulative parameters beginning at a specific date. And also you have summaries, so you can keep track, have a daily summary, have a weekly, monthly summary. So I just went in just to check it out. So it was August 2013, so last year in Summerside, get summary, and then you get all the specific elements, days with precipitation, and also the cumulative evening degree with different days. So there's all sorts of information available. You may want to track precipitation. Normal precipitation for, let's say, August is 90 millimeters of rain, and I want to know, well, so far, like, is this drier, wetter than normal? So you can see the departure from normal. And then there's a specific also crop that you can select, and there's not necessarily a lot of information in all of them. But I know I was just checking in potatoes, and you may go in the summary section, and you see in Kings County, so we have all the stations I talked about, and you can have a follow-up of the progression on how the crop is doing. Well, thank you very much.